Welcome AP Environmental Science students. This is Mr. Pembroke and we are going to talk about watersheds today. For this lecture, we are in topic 4.6, which is watersheds. And again, we are with the same enduring understanding that we've been with for the past few videos. Earth systems interact, resulting in a state of balance over time. And the learning objective here is to describe the characteristics of a watershed. The only vocab here is a watershed, which in the United States is also known as a drainage basin. Not everywhere around the world, but at least in the United States. So when you use the terms in this class, you should use the term watershed, and you will see watershed on pretty much every AP question. You will not see drainage basin. However, it is also known as drainage basins, at least in the US. Drainage basin has its own separate term if you're in the UK or the rest of the world. But people in the US will often describe a watershed as a drainage basin. Okay, so you might hear that term, but in this class you should use the term watersheds. Okay, this is land area that channels all precipitation that falls that does not infiltrate the soil and stay in the soil into creeks, streams, rivers, as well as the subsurface flow that's flowing into those creeks, streams, and rivers, and then eventually into a large inland lake or the ocean. Okay, what do I mean by large inland lake? Well, it could be the Great Basin in the western United States, where the Great Salt Lake is one of the largest, or is the largest body of water in that basin, where many tributaries flow into the Great Salt Lake, and they never outflow back into a river to the ocean. Okay, but most of the time it's going to end up in the ocean. Most surface water on the planet eventually ends up in the ocean just through downward flow. Okay, so in this diagram up here we have a high ridge of land. So all of this in red is the high land, and it is separating this one drainage basin that's marked from all of the other drainage basins. Okay, so any precipitation that falls on this is all going to, what doesn't infiltrate into the soil, is going to run off the surface of the land and go into these creeks and streams, eventually forming this larger river. Okay, even some of the water that does infiltrate the soil is going to flow steadily through the soil and feed these creeks and streams. And these ridges of land, what I outlined in red, is going to separate this from another drainage basin. So you might have another creek flowing this way and another creek flowing off of that side, eventually forming another river. Okay. So when you're talking about drainage basins, or sorry, I even fall into that trap. When you're talking about watersheds, your scales can range in size from very small, tiny little watersheds to thousands of kilometers squared watersheds. Watersheds that cover entire continents, or at least very large portions of continents. Okay, so like, are you interested in a small alpine lake, or maybe your small alpine lake is your entire watershed? Maybe this small little watershed terminates in an alpine lake, and there's another high ridge of land right there, and there's not enough water there in that lake or in that watershed in total for that water to spill over the side there and fall into another watershed. Okay, maybe it's just a small little isolated alpine lake and there's not much water there, so it's a small little watershed. Or maybe you're talking about a watershed as large as the Mississippi River watershed, which covers, or which drains about a third of the contiguous United States. Okay. These can also range in size depending on what you are interested in the specific watershed. Okay, so it's kind of like Russian nesting dolls, you know, like where there's a small little doll inside of a larger doll, inside of a larger doll, inside of a larger doll. We're looking at the same thing. So, for example, with the Mississippi River watershed, Colorado has Clear Creek. If you are driving up I-70 into the mountains, you are driving alongside Clear Creek. Clear Creek originates near the Loveland Ski area. We'll actually talk about it a little bit later, but it originates around the Loveland Ski area. Okay, the Clear Creek is going to drain into the South Platte River just like northwest of Denver, or just west of Denver. Okay, the South Platte River, though, is then going to join the North Platte River in Nebraska and form the Platte River. The Platte River is then going to join with the Missouri, which is then going to join with the Mississippi. And then the Mississippi is going to flow into the Gulf of Mexico. All right. So are you interested in just Clear Creek? Maybe you are like a water engineer, or maybe your Coors Brewing that's in Golden, or maybe you are a small farmer near Golden, and you are just interested in Clear Creek. All that you're interested in is the water in Clear Creek and how clean is it, how pure is it, what's the flow rate, and how can I use it, right? Or maybe you are a farmer on the Platte River and you have to worry about all of the pollutants being released by everybody upstream of you, right? You have to worry about everybody and the entire South Platte River drainage basin, the entire North Platte River watershed, and all of the pollutants that they're releasing going into the Platte. Or maybe you were in New Orleans and you're worried about all of the pollutants that are released throughout the entire Mississippi River watershed, right? About a third of the contiguous United States. So some characteristics of watersheds. We could be looking at just the length of that watershed, right? Again, are we looking at the Mississippi, or are we just looking at a tiny little creek right over here, right? Up in the Rockies. Okay. Are we looking at the area? So again, the size of it. The slope. So when you're up in the mountains, the slope is going to be much steeper, and therefore, if you look at this image down in the bottom left, your water is going to flow down and then a waterfall, and then flow down, then waterfall, and then flow down, and then waterfall. And that waterfall is going to aerate that water, and you're going to get a lot of dissolved oxygen in that water because it's aerating so much during every one of those little waterfalls going down, right? Your flow rate is going to be a lot faster, but your water or your waterway, your creek is typically a lot smaller. There's not as much volume as there would be if you were down here near New Orleans at the mouth of the Mississippi. Okay. Once you were down there, your flow rate is really slow. Once you're right near sea level and there's not much hill country, not much change in elevation, your flow rate is going to be really slow, and it's going to create a really wide meandering river that's going to flow really slowly and probably be pretty turbid, meaning that this is not a word that we've talked about in this class yet, but turbid is essentially the clarity of water, essentially how murky it is. Okay, so if it's very turbid, high turbidity is going to be very murky, whereas low turbidity is going to be very clear. Okay, but again, not really a vocab word for right now. We don't need to know it right now. But since I used it, I figured I'd define it. So down here, not a very huge change in elevation. You're going to have a slow-moving, meandering river with a huge volume that's going to be relatively murky. Okay. The soil type can influence what's going on. So if water is dissolving the soil, dissolving the rock as it moves down, you can have different characteristics, different minerals in that water. A little bit beyond the scope of our class. Vegetation. Vegetation is key, which we'll talk about in a little while. But if this is a desert mountain, it's going to erode faster. You're going to have more sediment in your water because that water is eroding the way that hillside. Whereas if you have lots and lots of vegetation holding that soil together, it's going to release water from that soil very slowly, like we'll talk about in a little bit. And it's not going to erode that mountainside quite as much. The type of precipitation, so are you talking about snow or are you talking about rain? Snow is interesting in the fact that it melts over a long period of time in the spring and summer. So you'll have a constant supply of water, whereas if it's just rain for 2 months out of the year and then the rest of the year is dry, you might have a seasonally dry watershed, a seasonally dry creek or a seasonally dry river. The infiltration properties of the soil, how much water infiltrates into the soil, so it goes right into the soil and then eventually hits like impermeable rock and forms a spring. Okay, and again, we'll talk about that in a little bit. The groundwater flow, the rate of groundwater flow, whether there is groundwater there or not. again, a little bit more beyond our class, and then the divides between the watersheds. Okay, so right here is a divide in this red between two watersheds. On the right-hand side, you have one watershed going down into one river or one creek, and then on the other side is another one draining down into another creek. Okay. And then what I want to point out also on this is subsurface flow. So that groundwater, that infiltration, when you have some subsurface flow, it will infiltrate the soil and then flow again via gravity towards the lowest point of the land and then feed that river as well. Okay, typically coming out as a spring. Some functions of watersheds. If we are looking just at people, they are going to provide drinking water. They also provide drinking water for many types of animals, but for people especially, they provide drinking water. They provide habitat for all sorts of organisms. They help with soil formation. They help with soil transport and erosion. And then again, very human-centric idea, fishing and recreation. One thing that I should also mention was soil. When you have a floodplain, which is when you have a large river, low change, well, not even a large river, but any type of river, and you typically have a very little change in elevation, right? There's not huge banks of this river that's kind of a slow meandering river like the wide Mississippi. You will typically have, so we have our meandering river. This is a river. Sorry, my artistic skills are really poor. So a slow meandering river, and then it is spring and there's heavy rains. You will typically have it widen out into a larger river. This is the floodplain. Okay, so this area right here is the floodplain, and that floodplain typically has really, really good soils, and people like to farm in floodplains, which is why you hear a lot about how farming communities or old villages or old towns or even old cities that are right next to a river often flood because they are right there in the floodplain. The floodplain is the area next to some high land, so we got some hills next to the floodplain. That's going to keep that floodplain in a certain area, and it's going to be really, really good soils because it's bringing silts and especially silt, but other sediments down from upstream, and it's depositing those during the flood, and it's adding a lot of organic matter to those soils as well and creating really rich, fertile soils. Okay, so they are really great in soil formations, especially in floodplains. All right. Watersheds will filter and transport water, so they obviously are transporting water from the highlands down to the lowland, but they also filter water along the way. Running water, when it's fast running, tends to become clearer as water moves through soil, as water moves through the ground. So right, it rains here and that water moves through the ground, through the soil. That ground and soil will filter out that water, especially if it's running through sands, it will filter that water. And the water will be clean when it comes out of that spring into the creek. Okay. It also transports the sediments and water, which is what I was talking about here with floodplains. Okay. Sediments are going to carry nutrients that are going to create very fertile soils down here in the floodplain. All right. And then I have this quote from the Center of Watershed Protection in the United States, just talking about some of the human impacts that we have on this, just in terms of pollution. Right. So nearly half of U.S. rivers and streams and more than 1/3 of our lakes are so polluted that they are unfit for swimming, fishing, and or drinking. That was taken from a quote from 2020. So it's still a very modern issue, even though things are getting a little bit better. So a couple quick examples of watersheds. Watersheds are one of those things that I really like because you can see them when you're traveling. They're really just neat to look at when you're up in the mountains especially. But What I have here is two different watersheds forming a common third watershed. Okay, so if you were to go up I-70, so this is I-70 into the mountains, this is the Loveland ski area right here. So if you've gone skiing at Loveland, you probably know this, and you may know that there is a small little turnoff right here to go to Hermann Gulch. Hermann Gulch is a really popular hiking ground, especially if you like to see columbines. There's a lot of columbines in this gulch. And in this gulch, there is a creek that runs right through the middle of this. And it has its headwaters up here in all of this mountain. Notice that we have the high ridge, so this high land, that's separating, that is separating Hermann Gulch from other watersheds, specifically separating it from Watersheds Gulch, our second watershed, which is also separated by high land from other watersheds. Okay, so any rain that falls here or any snow that falls here is going to melt down and form a creek right about there starting, right? And you might have a couple other tributaries falling in that are forming what I'm guessing is Hermann Creek. I don't know what it's called, but the creek and Hermann Gulch. Okay, that is eventually going to pass under I-70 and flow into Clear Creek, which is running right along here. Okay, but the creek in Hermann Gulch is separate from the creek that runs right down the center of Watersheds Gulch, right? And it is fed by a couple other tributaries, and any snow, any rain that falls here is either going to just run off the surface or subsurface flow to form a spring and then feed the creek and Watersheds Gulch. These are two separate watersheds, all right? So the Hermann Gulch watershed and then the Watersheds Gulch watershed are two separate watersheds up in the mountains, and when you're standing about right here, you can see both of those watersheds pretty clearly. Okay, and they both form kind of a bowl shape or a gulch shape. And then both of those eventually drain down into Clear Creek. Clear Creek is the larger of the three watersheds in this, and once they are at this point with Clear Creek flowing in this direction, right, they are back to one watershed. All right, but right here they are two separate watersheds. So it's really cool just going up into the mountains and looking at watersheds. A lot of the times you can see just one mountain and the one or two or even three or four watersheds that are coming off of the different sides of that mountain. Another quick example, which is maybe a little bit closer to home for you all, is Piney Creek. Piney Creek flows right outside of GHS. So right here is Grandview, and if you know this trail, you're pretty familiar with it. So if you were to like take a molecule of water or some molecule of pollutant that you could trace and put it right here from the corner of Arapahoe and Liverpool and follow it all along this creek, you would find that it is traveling in this direction and that it is eventually going to go into the Cherry Creek, right? And then eventually the Cherry Creek is going to meet the South Platte River in Denver, which is going to go and join the North Platte, which is going to join, become the Platte River, which is going to become the Missouri, which is eventually going to join the Mississippi. So if you were to be able to trace one molecule of water from right outside Grandview, you would eventually find it in the Gulf of Mexico, which is what this is showing also. So this is just one tiny portion of the Mississippi River watershed, just showing from Piney Creek all the way down that pathway to the Gulf of Mexico. All right. So this map I really like. This is a color illustration of all of the watersheds in the contiguous United States and the lower 48. And we see the pink in the middle of this map representing the Mississippi River watershed, which again drains about a third of the contiguous United States. And then you see some of the major rivers like the Columbia up here in the Pacific Northwest. You see the Sacramento River in the Central Valley of California, the Colorado River. Right here in this more fuchsia color is the Great Salt Lake Drainage Basin. You have the Great Lakes up here, and many of the other rivers in the United States. You'll notice this third blue one that's originated in southern Colorado. That's the Rio Grande. All right, so the three major ones coming from Colorado are the Colorado River, the Mississippi River, and the Rio Grande River. So one of the major roles of watersheds is filtering and transporting water. All right, so if we take a general hill around the planet, we're going to see that most hills and most mountains tend to be more vegetated than the areas around them. They often tend to be forested. And the reason for that is because they are at elevation, they are squeezing out the precipitation from the clouds that are moving over them. And obviously, I'm just speaking in generalities, but exceptions do exist. But if we think about anywhere where there is rain, anywhere where there is a relatively large amount of precipitation to create a steady flow of water, we're going to see that these areas are more heavily vegetated. All right. And the vegetation that's on those hills, on those mountains, is going to intercept any precipitation. So if you think about a really heavy driving rain and you're in a forest, if you're underneath the trees, it might just be dripping down because the leaves of those trees are intercepting all of that precipitation. They're slowing it down towards just dripping to the forest floor, and it's allowing it to absorb into the soil really slowly. As it slowly absorbs into the soil, it's going to start to move through the soil and rock until it hits something impermeable, and it's going to come out as a spring. So I have a couple examples of a spring. Here you notice that in both of these examples, even though that these ones on the top look like waterfalls, there is no water above the point of exit right out of the ground. Those are springs. It's just areas where the water flows directly out of the ground because of the geologic features of that area and because of that groundwater flow, all that water that's moving underground. Okay, and because you have this slow release of water from these springs from a large reservoir in the ground or a large store of water or a large slowly moving body of water in the three-dimensional matrix of soil and rock, you are going to have a steady supply of clean fresh water. Remember that this soil, this rock, tends to filter that rainwater. Okay, it's not going to come out as dirty, gross, soily, mucky water. It's going to come out as clean spring water. So the example that I have for the importance of the watersheds and supplying that water, of filtering it and moving it for human use, is the Taita Hills in Kenya. Okay, so if we look at the Taita Hills on this top, and I'm not sure if I'm pronouncing that right at all, but those are the hills, and you can see that from Tsavo National Park, it is very, very arid in the savanna. But you get up to those hills and it's a cloud forest. Now a cloud forest is where clouds will move over, clouds maybe from the Indian Ocean are going to move over to that area, and they're going to be at the same elevation as that forest, and they're just going to form dew in the morning, and the clouds are just going to move through, and they're going to deposit a lot of water right onto the vegetation, like right onto the leaves. That's going to drip down to the forest floor without it actually raining. So it's mostly supplied by clouds. Okay, so that forest is going to intercept the clouds, which is going to condense, forming dew at night, which is going to drop down in the soil. That happens pretty much every day. And that leads to a slow influx of water into the soil, which is going to have that subsurface flow to create springs, which are going to feed creeks, streams, and eventually river. Okay, that's what the system should be. And right here, you can see the agriculture at the base of those hills is thriving, and it's very, very green compared to the very arid savanna next door. All right. Local conservation groups are constantly working against deforestation here because they realize the value of all of this water for irrigation for the cities of Kisumu and Nakuru. And again, I'm probably pronouncing those wrong, the third and fourth largest cities in Kenya, so right here and right here. These hills supply the majority of their fresh water. Right, so it's much, much more important to keep this forest healthy, to keep that watershed functioning, than it is to deforest that area, to disrupt the interception of those clouds, forming that dew, creating essentially dry, barren hills where there was once forested hills, and disrupting the flow of water downstream of these hills, all right, off of this watershed. All right, so back to the learning objectives. So characteristics of a watershed, you guys should be able to describe the characteristics of a watershed. Those characteristics include its area, its length, its slope, soil, vegetation types, and the divines with adjoining watersheds. I actually spent a lot of time here talking about the filtering and transporting function of water through watersheds, because that really is one of the most important things that you'll see as we continue talking about watersheds throughout this course. All right, anyway, I hope you guys learned something, and I'll see you all in class. Bye.